Hello everyone, we are Sub-Project 5. The goal of our study is to improve the security of communication between SFs and other components in the near-real-time RIC. In the near-real-time RIC, SF usually communicated in two ways, IMAP message and REST API. First, based on two known CVE vulnerabilities, we recreated the flows in SL communication. On the left is CVE 2023-42358, which shows that when an SF uses a REST API without any control, it can shut down an E2 node. On the right is CVE 2024-34473, which shows that if error messages are abused, they can be hijacked so that the E2 node cannot connect properly with the E2 terminal. To fix these two vulnerabilities, this study adds two new functions, automated detection function and OAuth authentication and authorization function. The automated detection function is a detect that runs during deployment. First, we create a blacklist of error message and REST APIs that should not be used by third-party XFs. When an SF is deployed, the deployment tool checks its deployment files for any blacklist, IMR message, or REST API. If it finds any, it blocks the deployment. However, because REST APIs are open by nature, checking only at deployment time cannot stop an illegal API calls. That is why we added the OAuth authentication and authorization function and integrated it into AppNGR. After an SF is successfully deployed, the deployment tool registers its REST API information in the SF registration list and generates a hashed password from its name. This password is sent back to the SF. Whenever the SF wants to use its REST API, it must use this password to get an OAuth token before sending the API request. The registration list contains the SF name, the hash password, and its REST API registration details. When an SF makes a REST API call, it first needs to request an OAuth token by providing its identity and the REST API path. Then, the OAuth authentication and authorization function verifies the request. If it is valid, it returns the OAuth token to the SF. After that, the SF can call the REST API using this token. When the SF sends a REST API request, the API verifies whether the token is valid and only returns data if the token passes validation. Next, for the demo, we will show two parts. First is automated deployment detection. We will demonstrate the SF deployment process and show how a malicious SF is blocked. Second is OAuth authentication and authorization. We will show an SF making a REST API request and also demonstrate what happens when an SF uses a fake token or an expired token. And this is the first part, automated deployment detection. We start by showing the result of deploying a malicious SF. The deployment package contains illegal IR message and REST API calls. After we try to deploy it, the deployment tool blocks it and shows the illegal control command. Next, we delete all the illegal commands from the deployment package and deploy again. Then we type install to reduce its charge info. This time, the saved SF is successfully deployed to the near RTRIC. And this is the second part of demo, all of authentication and authorization. The SF needs to get the health status of AppNGR. We will show three scenarios. First, the normal REST API request. Second, using a fake token. Third, using an expired token. All of this follows the OAuth 2.0 standard. First, in the normal flow, the SF uses a password to get an OAuth token. Then it uses this token to send a REST API request. You can see that with a valid token, it successfully gets the data. If it uses a fake token, the screen shows that it cannot get the data. If it uses an expired token, even though the token was valid before, it still cannot get the data. In this case, the SF needs to get a new OAuth token with the password again. And this completes the demo for our research. Thank you for listening.